Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about entity relationship model. What is an entity relationship model or an ER model? What are the basic structures of ER model? How to define the entity sets, the attributes, the domain of attributes, the relationship sets, and the all features that is we can use in the ER model. The entity is an object that belongs to any of the enterprise of which database we are storing. For designing purpose for the database, we need an relationship between the objects or the entities. For that, we need a modeling structures. So other than many models, we choose ER models because it is very simple and clear to have the ER models. So the ER models are generally given with the entity as an object, and between the entities they will prescribe some relationships. Now when we talk about entities, the entity can be discrete and concrete and also abstract. The entity can be, say, for a bank enterprise, it are the branches, the customer, the account, and the loan, and the obviously employees to the bank. Now from here we say the customer and the employee are the concrete entities because they exist in real. And the abstract entities are the account number, the branches, and the loan. That means they are conceptually there, but they are not existing. That means they are not living being. So in this way we can derive the concrete and the abstract entities. An entity set comes with the idea that are the same type of entity. Say for an instructor for every department, they form an entity set instructor. So the instructor entity now be given and transferred to the instruction set or the instructor entity set, which will consist the information about all the instructors of an university. So that is the same type of entity we are dealing with. We need to introduce an entity set. Now for the entity set, there should be some attributes that we need to define to properly say what are the features of that particular entity. Say for the instructors, there should be an instructor ID, the instructor name, their salary, and the department to which it belongs. Now that the attributes we have defined, we must specify a primary key to uniquely identify that particular entity inside an entity set. Now, other using entity set for an abstract view, we use the keyword extension, that we are actually extending the entity set. When from, say, account we are extending to savings account and current account, that is the form of extension we provide. Or we can say we are actually specializing the entity set into a more derived form. Now the entity has got the attributes, and also the attribute has got values in it, so that we can actually deal with the entities. So the values like the person ID or the names, see that the attribute names, and 101, 102, Kim, Kurt, these are the values to the attribute names. Now let's look at an instructor and student entity and what are the values or attributes we have got there. So these are two entities, instructor and student. So we can say that the instructor is an extension of the person entity, as well as the student is also an extension to the person entity. Now the instructor, I am describing the two attributes, the ID and the name of the instructor, as well as the ID and the name of the student. And this has got some concrete values against the instructor ID and names, which is a pair, Crick, Kurth, Jones and Smith. And for student 2, we have got some values like Helen, Cover and Gina. So what will uniquely identify the student and the instructors from a person entity? The ID of the instructor as well as the ID of the student. So in this way, we are generally deriving the entities and the values of the attributes to define the entities properly. Now that we have talked about extensions, we should know that the extensions can be specializations to this. It can be disjoint or operable. Now when it is disjoint, then we must say that a single attributable entity is inherited from its father entity. Say for instance that a child can have relationship father and mother to his parents. So we can uniquely identify father relationships to his father and mother relationships to his mother. Or we can have the parent relationships as a combination of a father and mother name to the child. So it is entirely dependent upon the database that we are actually storing the data, that we need the father name and mother name explicitly or separately or not. If it is prescribed, then we should use the other form of the representation. Otherwise, we can use the combination of a parent relationship to the child. So this is for an example. We can have more examples on ternary and binary relationships. Now, what is a relationship? A relationship that it really connects two entities. That is, one entity is connected in a relationship way with another entity. Say for an example that a student and the instructor has the relation advisor. So when we say a student has an advisor or the instructor, that means the instructor being an advisor to the student. That is, a relationship advisor exists between an instructor and a student. Now, is the student a person or is an instructor is a person? Both the results are true because the person inheritance in an is a relationship between the student and the instructor. So the person is either student or the instructor. Now that we know that what is a relation, we must talk about relationship sets. So a relationship sets belong to an entity set that has a common type of entity as their part. So say for a banking enterprise, if there is a works for relation for the bankers or the customer being a borrower to the loan, and the account has got a branch with the account branch relation, loan has got the customer as in a borrower, again loan has got a loan branch to the branch. These are the relations that has the common type of entity sets of all around the data bank. Now we can take this as a relationship set because it belongs to an entity set. So we can formally define it as if n is greater than 2, that means the number of the entities is greater than 2. Obviously, because if there is no two entities, then we cannot establish a relation between them. So if it is greater than 2, then E1, E2, En are the entity sets. So R is the relationship set that we can compare from it that every relation belongs to the entities. So this is the formal definition that if E1, E2 to En are the relationship sets of R, then every relationship must belong to some of the entity sets if there is existing of two or more than two number of entities. Now that we call the E1, E2, En as the entities in an ER model, but when we are talking about the relationship sets, we can call them a participant. So the entities are the participants of a relation. Or we can say that the relations are an instance of that entities. Now say we are talking about the role. So the role is that an entity got within relationship. So say what the employee it the works for. So what are the works for relationship? That a manager can be a worker's manager, or the worker can be the worker of a manager. So in this way we define the roles, that the instructor being an advisor to the student. So what is the role of the instructor in this relationship? That is the being an advisor. Now we talk about the relationship instances. First, let's look at the example. Now let's look at this. That is an instructor and a student being the relationship advisor. So when the advisor of an instructor to the student relationship exists, then we can say that there can be one instructor being an advisor to many of the students. So we are specifying about the relationship instance. The Creek has a relationship with Helen for being an advisor. The Karth, which has got the ID 862, has been an advisor to the 5621 Cover and 1432 Gina. Now see that a relationship instance even got that more than one tuple or information. The first one, that is single relationship within a Creek and Helen. But it is always considered as an instance even if it has got two or more than two information. That Karth being an advisor to Cover and both Karth being an advisor to Gina. So in this way we can say that we are dealing with the instance, not looking at we are having a single instance or in multiple instances. Now if an entity set participates in more than one relationship, so we can have in this way that first one relationship is existing, then we can have from the relationship derived another relationship. This is known as a recursive relationship, so that we can get the first relationship after being related with the second one. Let us look at an example. Say we are talking about the course relation or entity. Now here in the course entity, the condition constraint is that one student can be attached to one course if he has got some prerequisite course. Now we will add it to the student table first. Now see that look at the student entity again. Helen has got the course ID 202, which is the prerequisite of the course ID 101. Now the Hood has got 305, which is the prerequisite ID 202, so which in turn the prerequisite ID of 101. So that is known as the recursive relation that exists inside a course relation or an entity. So the course relative with a pre-requirement with itself, so that I will get only the course ID after I fetch another course ID from it. So the 202, 101 and 305 is the 202. So the prerequisite can be the course ID itself because it is of the same type. So in this way we can have a recursive relationship even in the same attribute on the entity set or in the other different entity sets. Now we will talk about the descriptive attributes. Say for an example, if we want to describe a relationship, we can add even an attribute to the relationship itself. We know that entity sets are generally considered the primary ones to have the attributes to define themselves. Now we can add an attribute to the relationship so that we can define the relationship or we can describe it properly. Say for an example, for the instructor and student, the relation is being advisor. Now I want to add the constraint or the definition of the relationship advisor, that an instructor will be a student's advisor when the students got admitted and being attached to the instructor. So the instructor by itself is not an advisor. It will be an advisor when he got a join date of the student. So now the relationship will look like see that I have added the attribute date to the relations or the entities instructor and student. Now our relationship advisor is defined over the attribute date. So we can have that Crick has got Helen as an advisor on June 2013. Now see at this one. Cart has got the June 29 Covert's advisor and at April 2010 Hood's advisor. So we got two relationship instances based on the definition on the relationship advisor. That the date attribute specifies that the cart being advisor to do of the different cases. Now if there is repeated date to the advisor, it does not mean that it has to go to the relationship instances. Say for example, Jones being the advisor of Gina on May 2010 as well as Speed with the advisor of Avoy on May 2010. So it doesn't mean that these two relationships are same because of the relationship definition. So other than using the attribute as a part of the relationship set, we need to consider all the participants of the relationship as a make to an instance to the relationship. Now some of the entities have got different relationships between them. Say for an example that an instructor and student has got an advisor relationship. It is also possible that an instructor and student has got different types of relationship, like as for the department advisor. Say for now a student being a part of the department and the instructor also being the part of the department, and department wise they can also advise the students being on an administrative basis. Now the Jones can be the advisor of the department advisor of Helen as well as Scott can be the department advisor of Avoy. Now we can have another relationship that is a department advisor to the student along with the relation advisor that existed previously. Now we will talk about the binary and the n-ary relationship. We can have between two entities or more than two entity sets one relationship set. Say for we are considering the instructor and the student. So there exists a project guide relationship. That is an instructor being a project guide to a student. So we can have another entity that is a project entity will be attached to it, because other than being a project, we cannot be a project guide or an instructor to the student. So first we need to be on a project, then the instructor can be the project guide for the student. So now the relationship lies on that the project guide with the relationships on the entities student, instructor and project. So the project guide will consider a set of the instructor, the project and the student as a part of it. So this forms a more than one binary or a ternary or a quaternary relationships. So this is basically an n-ary relationship. When I am talking about n-ary relation, that means that more than 2. So n can be greater than 2. Now we can also have binary relationship just like the instructor or the student advisor. So the advisor relationship has got only two entities, instructor and student. So the number of participants in a relationship determines the degree of the relationship. That is here the cardinality of the relationships. It can be binary, ternary, quaternary, and so on. Now the attributes are the fields or the components on which an entity is defined. Say for the instructor, the ID and name as the attributes. Now the attribute has got some real values like 765, quick, 862, Kurt, and so on. So it can be a combination, it can be individual and attribute. Now we will talk about different type of attributes that we can have inside an ER model. The first is the single and multi-valued attribute. Single valued attribute means that the attribute can have only one value. Say for the ID field of the instructor, an instructor can be associated with only single one ID. So this is known as a single valued attribute. Say Jones is associated with 350. No other ID can be provided to Jones as an instructor. Now when we talk about a multi-valued attribute, that means the attribute has got or can have multiple values. Say for the contact number of the instructor, there can be the home, office, or work contact number for that particular instructor. So we can have multiple values to the attribute contact number or the phone number. Next it comes to the composite and the primary attribute. When we talk about a simple attribute, that means that is an atomic attribute and that cannot be broken further. When we talk about again ID, that ID cannot be split into two or more attributes. So that is the simple or the primary attribute that we are talking about. Now when we consider a composite attribute, that can be composed of two or more simple attributes or primary attributes. Say if we take an example of a name, the name can consist of the first name, the middle name, and last name. Now we will know about the component attributes. Before knowing that, let's look at this tree. When we talk about an address attribute, we know that the address can be split in street, city, state, and zip code. So that is a composed attribute. Now, what happens if any of the composed attributes also can have another attributes? So that will be considered as a component attribute to the part of the composed attributes. Say for this example, now the street can be again split into street number, street name, and apartment number. So that will form the components of the composed attribute street, which is a part of the address attribute. So these are the composed and component attributes. Next we will know about the derived attributes. Now derived attributes are attributes that can be derived directly for another attribute. That is one attribute's value which can be calculated and be used as an synonym to the attribute that we have defined. Say for an example, if we are talking about the date of birth. So if we have given the date of birth, it can be easily said that equals to age, because age can be directly calculated from the date of birth from the current date. So current date we all know, and the database system will also know by any of the management systems, and the DOB is given to him, then it will calculate the age from it. So age will be always considered as a derived attribute. Now we can also put null values to any of the departments or the sections inside the particular C. Now when we have null values, First, we need to omit them for any type of calculation purpose. Say, if we do not have any of the course names that is a prerequisite to another course. Say, for the example, if we have a prerequisite to 101 course, that is the starting course, so it will be null. So we cannot perform any of the operations on the field null, but it is still valid to have a null value inside an entity set's attributes positive value. So in this way, we can define all the parts of an entity relationship model, and after that we can build an ERD or the entity relationship diagram based on this model to form a conceptual schema of a database. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.